Hello everybody. In this particular class, we shall look into representation of negative number and 2's complement arithmetic. So, we had got introduced to number system in the previous class, but in that we did not discuss how to represent negative numbers. So, we shall cover these concepts, how to represent it is through sign magnitude representation, 1's complement, 2's complement, how to do binary addition and subtraction, and how to perform 2's complement arithmetic. So, sign magnitude representation is very simple. Okay. So, we have a sign bit specially placed which is towards the left and leftmost side considered as MSB, most significant bit, and rest is the magnitude. Okay. So, any number, the magnitude part will be represented here, right, and the sign part will be represented here. So, sign, if it is 0, we consider it is to be positive, 0 is taken as positive and 1 is taken as negative. Okay. So, this is the convention. So, in this, if we have got 8 bits to represent a number, okay, and we are considering say integers only, and fraction can be taken up later. So, this 0 0 0 0 0 0 0 1, okay. This 0, this particular bit is the sign bit. So, this 0 means, so this is positive, and rest 0 0 0 0 and all these are 0 and this is 1. So, in the from the previous class discussion, we know that this gives a magnitude in binary which is 1 only, because it is unit place 2 to the power 0 multiplied by the coefficient 1, and rest of the cases the coefficient is 0. So, it is only 1. So, this is plus 1. Okay. So, how will you represent minus 1 in this convention, in this representation? So, the magnitude part will remain same, only the sign bit changes from 0 to 1. Okay. So, if we have 1 0 0 0 and 0 0 1 like this, 1 6 zeros and 1, then we know that it is minus 1. So, this one over here is not associated with the place value that 2 to the power something that we have seen before. Okay. So, it is not 2 to the power 7, right. So, this is only a sign bit, right. So, similarly, if we consider say this particular number, how do you, what is this number? So, 0 is here. So, 0 is positive, this particular sign bit. So, this is 1. So, 16, this is 4th place, 4 20, and this is 2's place. So, 2, 16 plus 4 plus 2, so 22. So, this is plus 22. So, other bits remaining the same, 0 becomes 1, this is minus 22. In the last class, we had seen if all these are 1, right, this is 127, you can also calculate like 64, 32, etc., right. So, this is 0 means plus 127, this is 1 means minus 127. Okay. So, in this representation with 8 bits, what we can represent? We can represent from minus 127 to plus 127, right, minus 10, etc., etc. So, that makes actually 2 into 127, 254 and 0. So, 254 number getting represented by 8 bits, okay. And in this 0 is represented twice, like one here, another there. Okay. So, one representation is mixed, we missed. With 8 bits you can have 2 to the power 8, 256 representation, here only 255 numbers get represented. So, this is one way of representing it. Another representation is for negative number is called 1's complement number. Okay. So, in 1's complement, what do? We just take a inversion of the positive number. I mean, we take a complement of the positive number. So, this is the positive number, the first bit is the sign bit, right. So, 0 0 0 0 0 0 0 1 plus 1, that is the way we have seen it before. Okay. Then you just take inversion of it. So, 0 become 1, 0 become 1, right, and this 1 becomes 0 over here. So, 1 1 1 1 and 1 1 1 0, this is the minus 1. Okay. Plus 22 we have seen before. So, if you just take inversion of it, so wherever 0 is there, it is 1, 1, it is 0. So, this is the corresponding representation, this is minus 22. Okay. So, plus 127 we have seen, so minus 127 is this representation. So, this is called 1's complement representation. So, in this also we have got minus 127 to plus 127, 0 included. So, 255 numbers represented, okay, and 0 is represented twice, one by this, another by this. Next comes 2's complement representation. So, in 2's complement representation, the negative number is obtained by adding 1 to the 1's complement. So, 1's complement first we are having, we know how to get, and after that you add 1, we will get 2's complement representation. So, for example, plus 1, this is plus 1, we have already noted. So, 1's complement we have seen before, add to it 1. So, this is 2's complement, all 1's, all 8 1's, this is 2's complement of representation of 1, that is minus 1. So, earlier all these 1 in 1's complement, it was another version of 0. So, this is not 0. So, this is different. Okay. Here all 8 zeros are only 0, all 8 1's are not considered as 0, right. Similarly, the same example of plus 22, if we see for minus 22 in 2's complement representation. So, 1's complement is this one, add to that 1. So, we get 2's complement representation of minus 22, right. So, that way we can continue, and we have if we look at say plus 126, this is the representation, minus 126 means you invert all the bits and then add 1, this is what you get for minus 126. 1 4 zeros, 0 0 1 0 is minus 126, 1 0 0 0 0, instead of 0 0 1 0, 0 0 0 1 is minus 127, and another representation that comes, which comes within the range, which was earlier outside the range, 1 0 0 1 0 0, right, rest of the bits remaining same, that is your minus 128. Okay. Because now 0 is not represented twice, 0 is represented not by this one, only by all 8 zeros. So, we could push one number over here, right. So, that is the 2's complement representation of 128, that is minus 128. So, the range here becomes minus 128 to plus 127, within that there is a 0. So, 256 numbers can be represented by this. Okay. Now, if I had 1's complement number, if we take another 1's complement, we get back the original number, isn't it? So, that we have already, we can understand. What happens if we have a 2's complement number, that is a negative number, if you take again 2's complement of it. So, let us look at the example. So, this is minus 1, all 8 1's. If you take 1's complement of this, we get all zeros, and then plus 1, it makes the 2's complement. So, this is 0 0 0 0 0 0 0 1, right. So, that is what? That is your original positive number plus 1. So, 2's complement of minus 1, I mean the decimal version of the minus 1, right, we get decimal version of the plus 1. So, this was minus 22, right, in 2's complement, and if we look at its 1's complement, right. So, this is 0 0 0 1, right, and 0 1 0 1, add to that 1, 0 0 0 1 0 1 1 0, what is that? That is your plus 22, right. So, 2's complement, again you do 2's complement, you get back the original number, right. So, minus again another minus, so you get the original number back. So, this we take note of. Now, let us consider how we can do binary addition and subtraction, okay, in the binary system. So, similar to decimal number addition and subtraction, the way we usually do, we can follow the same thing over here. So, first we look at the addition part. So, 0 plus 0 is 0, 0 plus 1 is 1, right, and 1 plus 0 is also 1, and when we add 1 and 1, right, it will become 2, 2 in binary is 1 0, right. So, this is called carry also, this is the 1 units place and this is the 2's place, the carry is there, right. So, when we add say 21 with 33, just 21 in decimal and 33 in decimal, right. So, 21 we represent in this manner, 16, 4 and 1, okay. So, this is the places these ones are there, 33, right. So, this is 32, 2 to the power 5 and this is 1, so 33, right. So, when you add them up, 1 plus 1 is 1 0, so this 0 comes here, 1 is the carry. So, 1 plus 0, this is 1, this is 1 over here, then 0 comes here, this is 1 and this is 1. So, 1 0 0 1 1 0 1 1 0. So, this is the number that we get, right. So, this is your 2 to the power 5 32 plus this is 16, that is 48, this is 4, that is 52 and this is 2, that is 2, 52 plus 2 54. So, you get this is the decimal equivalent is 54, and you can see if you do addition you will get 54, right. Similarly, you can do it for 23 and 101. As long as the result is within the range, we do not we can go on doing this. When it goes out of range, we have to we cannot get the right result, valid result, okay. So, this example we can also see that 1 plus 1 is 0. So, carry is 1. So, carry 1 1 again 0, another carry is there. So, 3 ones. So, 3 ones means 1 1 is the result. So, 1 he is here and carry is 1, and this 1 0 0 this is 1, then rest are 1 1 1. And again if you convert to this to decimal, you will get 124, okay. And for subtraction, so 0 to 0 it is 0, 1 to 0 it is 1, 1 to 1 it is 0, and when you subtract 0 to 1, right, then you have to borrow a 1 from the previous stage, so that will make it 2. So, 2 minus 1, that will make it, the answer will be 1, but there is a borrow 1 which need to be subtracted from the 2's place, the next higher weighted place, that need to be subtracted, that we need to take note of, okay. That is the concept of borrow, okay. So, you look at one example. So, 21 minus 2, right. So, 16, 4 and 1. So, 21 the way we had seen it before, and this is 102, okay. So, how do you do it? So, 1 minus 0, 1, so it is 1, then 0 to 1, okay. You have to take a borrow, okay. So, when you borrow, this is 1 0 becomes 2. So, 1 0, that is 2 minus 1 is 1. So, there is a borrow, this borrow is to be subtracted, okay, from the next higher bit over here. So, this 1 is subtracted from 1, you will get 0, right. So, 0 0 and this is 1. So, this is 16, this is 2 and this is 1, 16 plus 2 plus 1 19. So, you can see 19. Similarly, you can look at other example, right, and this is similar to decimal addition and subtraction. And when the sign when a smaller larger number is subtracted from the smaller number, okay, as is the case of say an example 5 minus 8, what we do in the normal decimal subtraction? We subtract from the we put a minus sign and subtract from the larger number, okay. So, basically minus of 8 minus 5, right. So, this number comes as 3 and then this is minus 3, right. So, similarly in this case also, if you require, you can do it in this manner, right. So, you just see that this is the larger number, then you subtract it, since this is larger number. So, sign is coming here, minus sign is coming here, because this is the sign bit, okay. Now, in this digital electronics or in the binary system, when we perform arithmetic and we have circuits, building blocks using gates and all logic gates, then we prefer 2's complement arithmetic for some inherent advantages. Okay. So, we shall discuss 2's complement arithmetic now. 2's complement number representation we have already seen. So, in these addition is a normal standard process, and in subtraction, when you have to do the subtraction part, okay, what we do, we get 2's complement of the original number to make it negative. So, subtraction is a number that is getting subtracted, okay, and then we add these two numbers. So, basically subtraction here also becomes a addition process, right. So, a adder block, a adder circuit can perform both the job of addition as well as subtraction, right. For that, when we are talking about subtraction, we have to represent the number in 2's complement form, okay, to make a negative number out of it. So, this is the basic concept. This is the basic concept, and how it gets done. So, this is the minuend and this is the subtrahend. So, subtrahend we are taking the 2's complement, okay, and then we are getting the difference. And addition is simple. Addition is a normal process, the way we do it. Say example is 83 plus 16. We can just, the way we have done it before, we can do it the same manner. We shall see that a 99 is obtained. Now, let us look at how 83 is 16 is subtracted from from 83 using 2's complement. Okay. So, 83 16 here, when we talk about this number, to associate the value of this number, we are talking about decimal systems, but actually we will be performing the operation using binary. So, first of all, this 16 is a subtrahend. So, subtrahend we have to convert it to negative number by 2's complement, right. So, this is the number in 16 when it is in positive. So, 16 plus 16. So, plus 16, its 1's complement is this one, right. Only this one place becomes 0, right, rest are 1, and then you add 1 to it, it becomes 2's complement. So, this is your minus 16. So, this is the first step. So, then this number 83, right. So, 83 is this one, 16 plus 64 plus 16, that is 82 and 1. So, this is 83. Okay. You look at the weights and then you add. So, then add to it this minus 16, 4 1s and zeros, right. And if you add it, the normal addition operation. So, 1 1, this is 0 0, then 1 1 0, this is 1 1 0, this is 1 1 1, this is 1, there is a 1 carry over here. So, this carry 1 1 0 and this is the final carry 1. This is what you get. And if carry is generated, discard it and the answer that you get is positive. So, the result that you get from this operation is to be finally understood by this manner. If there is a carry generated, discard it, right, and rest of the number is to be taken as the final answer, which is positive. So, if you look at it, this is 64, right, and this is 2 and this is 163. Okay. So, that is what you get, right. This is 64, 2, 66 and 67, sorry, this part. Okay. Is this clear, right? 67 in decimal. Now, we have to look at other combinations. So, for example, subtracting a larger number from smaller number and other things. So, we shall look into that aspect now. So, 16, earlier it was 83 minus 16, now it is 16 minus 83. So, for that what we will do? 16 will go as 16 like this, 83 we have to get minus 83, that is the subtrahend now. So, we have to get minus 83. So, minus 83 we can get by 2's complement, again we perform the 2's complement, we get this one, right. and then this 83 we these minus 83 we add, and this is what we get. And interestingly, in this case you see that carry is not generated. Okay. So, no carry. Okay. So, when no carry is generated, right, and the sign bit that you see here is say 1. So, we know that the answer that we have got is negative and in 2's complement form. So, this answer is of course, because of the presence of 1, it is negative, and entire thing is 2's complement form. So, if you want to know its magnitude, 2's complement, if you are not very conversant, then we have to do 2's complement of this number only to get the corresponding positive part of it, the magnitude part of it. So, this is what you get here 1011 1101. If you perform 2's complement of it, right, then you get 01000011. So, this is 01000011. So, this is 64, 2 and 1, so 67. So, that gives you the magnitude part, but you already know the answer is negative. Okay. So, when you are doing the binary to decimal conversion, right, then you convert it back to the normal number representation, right, do not use the weights on the 2's complement, the negative number, and you know the numbers are negative, number is negative. Okay. So, carry is not there, sign bit is 1, the answer is negative, and magnitude can be obtained by again performing 2's complement. So, 16 minus 83 we get minus 67, right. Result we shall get in this form. We know the answer is negative, no carry, sign bit is 1, and to get the magnitude we perform another 2's complement. Now, if we want to perform subtraction from a negative number, that is also possible, right. So, how we can do that? So, the negative number in the first place say it is 83. Okay. Same example we are continuing with different combinations. So, minus 83 we have already found to be 10101101 in the previous example. So, this is minus 83 and 16 is subtracted. Okay. So, basically it is minus 83 plus of minus 16. So, minus 16 we have already calculated minus 16 before. So, this is your minus 16, you add them up. So, this is what you get here, right. So, we have got a carry, right, we discard this carry, and if we see the sign bit here is 1, right, we know the answer is negative, and when the answer is negative it is in 2's complement form, and we want, if you want to know the magnitude of the value, I mean we have to convert from binary to decimal, then we have to take another 2's complement of it to find the magnitude. So, 1001 1101, if you take 2's complement of it, you get 01000011, right. So, this is your 64, this is your 16, this is your 32 rather. So, this is 2 to the power 5, 32, 64 plus 32 is 96, this is 2, 98, and this is 1, 99. Okay. So, 99 in decimal, and the number is negative because sign bit is negative, right. So, this is the one. Whenever you are adding positive with positive, and here effectively it is negative with negative, you have to be careful that it does not go out of the range. Okay. So, if it is positive and negative and negative and positive, it is always within the range, right. So, this is something that we take note of. And if you want to subtract a negative number, so negative number subtraction is what, I mean it is basically addition of two positive numbers. So, this is minus 16 to first place, this is, so this is your minus 16, right. So, since it is a subtrahend, it is there in the subtrahend, we take 2's complement of it, then what will happen? We will get back the original number, original positive number. So, that is your 16. Okay. So, this is these 16th place 2 to the power 4, right. So, this 16 and this is 83, this is 83 and this is 16. So, if you add them up, you get corresponding decimal equivalent of 99, right, and you see that this is sign bit is positive, okay, right. So, if we then combine the different things that you have seen, this is effectively a addition only. For subtraction, takes 2's complement of the subtrahend, add it with the minuend, discard carry if there is any. If the sign bit is 0, the answer is positive and can be directly read or interpreted. If sign bit is 1, answer is negative and in 2's complement form. Okay. If we want to know the magnitude, that means you want to convert from binary to decimal equivalent, the magnitude part, then you have to take the 2's complement of this number, and the number will come in the form of the way the weights are placed 1, 2, 4, 8, and then we can convert it and we can get the corresponding number. Okay. So, this is how we can go ahead with 2's complement arithmetic, which we shall be using. In the previous class, we have seen the normal integer representation, fixed representation. So, all these are very easily done, conveniently done using 2's point arithmetic. To conclude, sign magnitude representation has a separate sign bit. Using 8 bits, the range of numbers that can be represented using sign magnitude representation is -127 to +127. So, 255 different numbers can be represented using 8 bits. In 1's complement representation, negative number is obtained by 1's complement or inversion of positive counterpart. Okay. The range is again from -127 to +127, 255 different numbers can be represented by 8 bits. In 2's complement representation, negative number is obtained by adding 1 to 1's complement number, and the range we have seen here is -128 to +127. And when we perform binary addition, carry may be generated, and in binary subtraction, borrow may be there. Okay. So, these are the things that is similar to decimal addition subtraction, but here we are doing it with base 2. In 2's complement arithmetic, subtraction is done by considering addition of negative numbers. So, basically first we convert it to a negative number, the number that is there in the subtrahend, by taking 2's complement of it, then we add it with the minuend. For 2's complement arithmetic, rules can be framed to get the result of all possible cases of addition subtraction. That means a smaller number is subtracted from a larger number is subtracted from a smaller number. So, the presence of carry is ignored, and if carry is not there and the sign bit is positive, sign bit is 1, and then the answer is negative and its magnitude is obtained by 2's complement of the number. So, these are the different rules that can be framed and by which 2's complement arithmetic can be performed. Thank you.